Hey everyone, welcome to Data and AI Fast Track. I'm Louis Lee, Head of Product Marketing and Evangelism for APJ at Snowflake. And I'm absolutely fired up to be your host today. I need to tell you something before we start. 3,000 of you registered for this session. 3,000 people, yep, on a Friday afternoon. Some of you are in Sydney right now, some in Singapore, some in Tokyo, and some in Korea. Some probably still in your pajamas. No judgment. This is a safe place. But here's what that number really tells me. The world produced 120 zettabytes of data last year. To put that in perspective, if each zettabyte were a grain of sand, that's roughly 12 times the Sahara Desert. And someone's got to make sense of all that sand. That someone could be you. Quick housekeeping. Everyone here live earns a certificate of attendance. Post it on LinkedIn, tag @Snowflake, hashtag Snowflake Fast Track for your chance to be featured on our social channels. Attend all 6 events and you unlock an exclusive ebook from our speakers. We are currently on event 4 out of 6. You're well on your way. And drop your questions into Q&A panel as we go. Our speakers will tackle them live at the end. Now I know from the registrations that this audience is incredibly diverse. Students, data engineers, data scientists, architects, directors, consultants, career switchers, and people exploring data for the first time. Whether you're writing your first query this afternoon or you lead a team of analysts, there's just something here for you today. Here is your agenda for the next 60 minutes. What does a data analyst actually do? The real day-to-day from someone who lives it. The career roadmap, skills, jobs, salaries, and how to get there. Live Q&A. Your questions, real answers. Now, I've got 2 brilliant people with me today. Sue Lee, tech evangelist at Snowflake. So he's going to pull back the curtain on what a real day looks like as a data analyst. Not the textbook version, not the LinkedIn version, the real thing. And for those of you already deep in data engineering or data science, the analyst lens is where business impact starts. So please lean in. Also joining us today is Edmondo Rossini, Director of Education Sales for APJ. Edmondo works with organizations across APJ who are hiring data professionals right now. He's bringing real salary data, real job listings, and a concrete roadmap from zero to employed. And for those of you who lead teams, his insights on where the talent gaps are will be just as valuable. Think of it this way. If Sue shows you the way, Edmondo hands you the map, the keys, and the salary guide. If you're still wondering what to do with your career at 3:30 my time, we haven't done our job. But first, let's start with a question everybody Googles at 2 a.m. What does a data analyst actually do all day? I'll tell you what most people think. Spreadsheets, spreadsheets, and more spreadsheets. Maybe a pie chart if you're feeling fancy. Sue is about to blow that myth wide open. So everyone, give Sue a massive virtual welcome. Sue, take it away.
Thank you for being here today. My name is Sue Lee. Today, I want to talk about something that many people are very, very curious about. What does a data analyst actually do? And more importantly, how can someone become a data analyst in the age of AI? Because if you look online, you will see many different job posts: data analyst, data scientist, data engineer, AI analyst, and sometimes it can feel very confusing. So today, I want to demystify what data analysts actually do in real life and some insights. Demystify what they do in real life and share some insights based on my own experience. Before we get started, let me briefly introduce myself. My name is Sue Lee, and I'm a senior product marketing manager and a tech evangelist at Snowflake. Although I work at a tech industry, surprisingly, I did not start my academic career in computer science. I first majored in chemical engineering, and later I continued my master's degree in operations research and information engineering, and that eventually led me to my first job as a data scientist in Silicon Valley. I spent several years working on data science problems there. First, I worked as a data analyst at a computer vision startup, solving next billion-dollar geospatial problems. And then later, I joined Snowflake, where I worked as a product data scientist, and now I work as a tech evangelist. My role today is to help organizations and developers understand how to use data and AI effectively. And like the word evangelism suggests, which means to spread the good news I want to share today is this. You do not need a traditional computer science background to work in data. Many of the best analysts actually come from many different domains. It can be economics, physics, marketing, and sales. And because at the end of the day, data analysis is really about solving problems using data. Let me give you a slightly more realistic picture of what a day of a day as a data analyst might actually look like. Because many people imagine analysts spending the entire day building dashboards and, as Louis said, a lot of spreadsheets, but the reality is a bit different. First, the usual day starts with data. You log in, open your data warehouse, and start pulling the data sets you need. And sometimes the data set is already available, but sometimes it's not. And sometimes you discover the data set you need simply just doesn't exist yet. And that actually happens more often than you would expect. So the first question analysts often ask is, what does the data say? It's actually, where is the data and how can I get the data? So once you find the data set, the next challenge begins. The data is usually very messy. Columns are missing, formats are inconsistent. There are duplicate records, so analysts spend a surprisingly a lot of amount of time just cleansing and transforming data. In fact, there is a famous joke in the data world. It's that 80% of data analysis is cleaning data. And unfortunately, the joke is actually true. But one of the most important parts of the job actually happens before analysis even begins. Defining what the business is trying to measure, a product manager might ask, like, are users liking this new feature that we just launched? But that question needs to become something you can measure. So analysts translate that into metrics like daily active users, or known as DAU, feature adoption rate, user retention rates. So this step requires a lot of conversations with your business teams and stakeholders. Because the most dangerous situation in data analytics is when people think they're measuring the same thing, but they're not. After lunch is usually when the real analysis begins. This is where analysts explore the data and try to find patterns, maybe like a sudden drop in revenue, maybe it can be an unexpected spike in user activity. Historically, this required writing a lot of SQL queries and sometimes machine learning models and algorithms. But today, thanks to AI tools are making this process much faster and easier. Analysts can now apply AI directly to their data sets and even to unstructured data like support tickets, documents, chat logs, like audio files and videos. And suddenly, data that used to be impossible to analyze and process becomes so accessible to you. But analysis alone is not enough. At some point, you have to explain your findings to your stakeholders. And this is where storytelling becomes incredibly important. And also, this is a time when you start creating your impact. Because your job is not just about explaining what happened, but your job is about explaining why it happened. And sometimes, even more importantly, what should we do next? So the best analysts are the ones who can turn messy data into clear decisions and actionable insights. And increasingly, the day ends with building some interestingly, the day ends with building something new. Instead of running the same analysis again and again and again, analysts now build tools that can automate the process and also provide self-service analytics. It can be a dashboard, it can be a data application, or nowadays it can be an agent that can answer business questions automatically. And that's why the role of the analyst is evolving from someone who manually analyzes data to someone who designs systems that analyze data. And the reason this role is becoming so important is actually very simple. Because today, almost every company is becoming a data company. It's not just about the tech companies. Like retail companies analyze customer behavior, banks analyze financial risk, healthcare companies analyze patient outcomes, and even sport teams analyze player performance and game strategies. And across every industry, decisions are increasingly driven by data. And behind many of those decisions is a data analyst, someone who can take messy, complex data and turn it into something the business can actually use. So before we talk about the job itself, let's clear up something that confuses almost everyone. If you start looking at the job postings, you will see a lot of different titles but very similar. Data analyst, data scientist, data engineer, like you see here. And at first, it can feel like these are the completely different careers. So, what's usually the difference? In simple terms, each role historically had a different focus. Data engineers focus on building the infrastructure and pipelines that move the data, and data analysts explore the data and answer business questions. Data scientists build predictive models, and AI engineers build systems powered by machine learning or large language models. But something interesting has been happening over the past few years. It's because of the Gen AI, the roles are starting to converge. The boundaries between them are becoming much less rigid and it's becoming more fluid. For example, today many data analysts need to understand how data pipelines work and also need to build to set up their own data pipelines. And at the same time, data engineers are increasingly working with analytics and AI, and data scientists are spending more time working directly with data platforms. So while the title might look different, these roles actually share a very common foundation, and we call this like shared data skills. And the skills can involve a lot of things, but starting from SQL and querying skills, Python programming knowledge, data storytelling, understanding of cloud data platforms, and most importantly now, increasingly, the AI literacy. And these skill sets are becoming the universal toolkit across the entire data profession. And this is actually very good news because it means starting your career as a data analyst can give you the access to this entire ecosystem of roles. So the question is no longer which data role should I choose? The real question is how broadly can I apply my data skills? So earlier we've talked about what a typical day of data analysts look like, and we can simplify that entire process into four core stages of the modern data workflow. First is collecting data, second, engineering and preparing the data, and third, analyzing data using AI, and last but not least, communicating the insights with the stakeholders. And let's dive deeper into each of these steps. The first step of the modern data workflow is collecting the data. And while it sounds very simple, this step has been historically been one of the most biggest challenges in analytics. Data rarely lives in just one place. It might exist across different databases, different teams, or even different companies. And accessing the data has often required building pipelines, connecting APIs, and managing complex data transfers. And I also remember one project when I was working as a data scientist in Silicon Valley. We needed historical weather data across the entire US for the past 20 years. And at first, it sounded very simple, but just setting up the data pipeline to collect the data took almost 2 weeks. And we had to identify the data provider, request API access, build ingestion pipelines, and make sure the data was stored and updated correctly. And the experiences like this are actually very surprisingly very common in the data world. And historically, moving large data sets was often harder than analyzing them. For very large data sets, companies sometimes even had to physically ship storage devices because transferring terabytes or petabytes of data over the internet was simply too slow. But today, things are changing very rapidly. Thanks to the cloud, the cost of compute and storage has dropped dramatically, making it much easier to store and share data at scale. So modern data platforms now allow organizations to share data directly without copying it. For example, like Snowflake has a zero ETL data sharing, which allows the companies and organizations to share their data instantly without copying it or physically moving the data. And you can think of it almost like Google Docs for data. So when someone shares a Google Doc with you, they don't send you a copy of the document, but they simply grant you the access to the same document. And you open the file, you can read it, you can edit it, but the document itself stays in the original location and with the owner, right? So the data sharing works in a very similar way. So instead of exporting data sets, making copies, and moving around and building complex pipelines, the data provider simply grants access to the data set, and the consumer can immediately query the data as if it was their own. And the data doesn't need to be copied, it doesn't need to be moved. So it stays securely governed by the original owner. So with just a few clicks, organizations can start working with shared data almost very instantly. And truly, this is the moment where data starts at your fingertips. And this dramatically reduced both the time and the cost of working with large data sets. So time to insights and time to action will reduce by dramatically. And once we have access to data, the next step is engineering the data because the raw data itself is rarely usable immediately. So it can be messy, it can be incomplete, duplicated, or stored in formats that are very difficult to analyze. So analysts and data engineers need to transform the raw data into structured and data sets that the business can actually use. So historically, this process followed was what called ETL model, extract, transform, load. And in this approach, data set was transformed before it was loaded into the data warehouse. But modern cloud data platforms have changed this model. Today, many organizations follow what is called ELT. So it's extract, load, and transform. So instead of transforming the data first, we load the raw data directly into the warehouse. And do you know why this happened? It's again because of the cloud. It dramatically changed the economics of data processing. Compute power has become much cheaper, storage has become much cheaper. So the modern data platforms can process massive data sets directly. So instead of carefully preparing data set before loading it, organizations now prefer to store the raw data first and transform that later when we need it. So this approach also makes the data pipeline much more simpler and more scalable. Another critical responsibility of a data analyst is defining metrics to perform data analysis. So metrics are how companies measure success. For example, daily active users, customer retention, revenue growth, product adoption rate. So when I worked as a product data scientist, I spent a significant amount of time collaborating with product managers and business teams to define these metrics. Because before you analyze data, you must first answer a very important question. What do we want to solve after, and what does success look like? The most important part is that without the right question, you will never reach at the right answer. So defining these metrics require deep understanding of the business, and this is why domain knowledge is extremely valuable for your analysis as a data analyst. So once the data is prepared and metrics are defined, the next step is analysis. So traditionally, this involves writing a lot of code. So we write a lot of SQL queries. They might build like statistical models. And today, some artificial intelligence changing how analysis is done. For example, many platforms now allow analysts to apply AI models directly to their data. So even if they're not like machine learning experts, they can actually start using them. And at Snowflake, for example, we have capabilities and features called Cortex AI, which allow the users to run AI models and features directly onto their data, and also offer Cortex Code, which is we also offer a Cortex Code, which is a coding agent like vibe coding, and this also lowered the barrier for applying AI to analytics. So speaking of the Cortex AI functions, I would like to talk about another major trend in analytics. Recently, we've been seeing the growing importance of the unstructured data and the multimodal data pipelines. When people think about data analysis, they often imagine just structured tables, like rows and columns stored in databases, and the files we can import and export through CSV files and Excel sheets. But in reality, most enterprise data doesn't look like that at all. In fact, around 80% of enterprise data is unstructured. It lives in documents, emails, customer support tickets, chat logs, images, audios, and videos. And historically, extracting insights from this type of data was extremely difficult and is only available by a very few experts because it required building custom machine learning models and complex pipelines. But modern AI platforms are changing this dramatically. For example, at Snowflake, we have capabilities called Cortex AI functions. And these are built in AI functions that allow you to apply large language models directly to your data. So instead of building entire machine learning pipelines with like hundreds of code, you can simply call a function in your SQL statement. For example, just call like AI summarize, and you can summarize large volumes of customer feedback, and you can call like AI classify function to classify your support tickets or extract key insights from your documents. And you can do all of this directly inside your SQL, and that is the key beauty. So suddenly, unstructured data that used to be very difficult to analyze becomes part of the everyday analytics workflow. And when we combine the structured data with these new AI capabilities, we begin to build what many people call multimodal data pipelines, and pipelines that can process not only tables that are structured, but also text documents, images that are unstructured. So this expands what analysts can do with data and allows organizations to generate much richer insight. After analysis comes perhaps the most important step, communicating the insights and making business impact. Many people think the job of a data analyst is simply creating dashboards, but dashboards are just a little part of the story. A great analyst answers not just what happened, but also why did it happen? And most importantly, what should we do next? So the best analysts are strong storytellers. They help organizations turn their data insights and ultimately into decisions that we can take action on. Another interesting trend today is that companies are moving beyond dashboards. So instead of static reports and daily snapshots from the dashboards, organizations are beginning to build interactive data applications and now AI agents. For example, imagine asking an AI system, why did a revenue drop last week? An AI agent could automatically find the relevant data sets, run queries for you, analyze pattern, and explain the results for you. And this is what I would exactly do as a data analyst. And in this future, analysts in this way will increasingly design the systems that can actually enable these capabilities. And one key component that makes this possible is something called the semantic layer. This is where business logic is defined. For example, what exactly counts as revenue? How do we define an active user? What time period should we use? Without clear defined business logic, even the most advanced AI systems cannot produce accurate answers. So this is why analysts with strong domain knowledge will remain incredibly valuable. So, what skills matter most for aspiring data analysts? First, curiosity about the domain. You need to understand the business problem. And second, communication and storytelling. Insights only matter if they influence decisions. And third, technical fundamentals. Even though AI can now generate code for you through vibe coding, understanding the fundamentals is still very essential because you still need to debug the system, validate the results, and design the overall architecture behind the data. So while AI is changing how we work with the data, it does not eliminate the need for analysts. In fact, it's actually transforming the role. So in this new world, the role of the data analyst does not disappear. So it's becoming even more important because AI agents still need people who can define the right questions, understand the business context, understand the domain knowledge, and design the logic behind the data. So in many ways, the role of the analyst is evolving from someone who manually analyzes data into someone who designed the system that can analyze the data. And that shift of the paradigm is incredibly exciting. So if you're interested in becoming a data analyst, here are a few practical ways to get started. First, learn SQL. SQL is still one of the most important and powerful skills for working with data because most data sets live inside database. Second, learn some basic Python. You don't need to become a software engineer, but Python is extremely helpful for data exploration, automation, and working with machine learning tools. And third, practice working with real data sets. The best way to learn data analysis is by actually doing it. So, for example, platforms like Coursera offer a wide range of data analytics courses. And if you're interested in working with modern data platforms like Snowflake, we also have courses on Coursera as well that can teach you how to work with cloud data and AI tools in practice. And many of these courses include hands-on labs, so you can actually build pipelines, run queries, and experiment with data yourself. But the most important part, I think, is just staying curious. So because great data analysts are not just people who know tools, but they're the people who are curious about problems and constantly asking questions. So we're living in a time when data is becoming more and more important than ever. Artificial intelligence is transforming how we work with data, but rather than replacing our job, AI is actually making analysts more powerful. The ability to understand data, asking the right questions, and turn insights into decisions that we can take action on will still remain one of the most valuable skills in the modern workplace. So this is all I prepared for today's session. I hope it was helpful for everyone. And thank you very much for listening. And I would love to take some questions if we have later on. And I'll bring back Louis back to stage.
All right. Thank you. How good was that, Sue? Really, really, thank you. That was a true masterclass. I was actually writing some notes down while you're presenting, and two things really comes to my mind, and I thought it was really important. Having a curiosity mindset, right? I think that's really important in this, especially this era of AI, right? I reckon half of the chat just rewrote their career plan in the last 25 minutes. So now you know what the job actually looks like from the inside, whether you're brand new to data or you've been in the field for years. I think Sue just gave everyone something to think about. Now the question is forming in your head. I can practically see it through the screen. Okay, Louis, that's great. But what skills do I need? What do the roles pay? And is it too late to switch? Short answer, it's never too late. As I mentioned at the top, Edmondo Rossini is our Director of Education Sales for APJ. He works with organizations across the region who are actively building data teams right now. He knows what's on the job descriptions, and more importantly, what's between the lines. As a Snowflake CEO, Sridhar Ramaswamy says, there is no AI strategy without a data strategy, which means there is no AI future without people who understand data. Edmondo's going to show you exactly what that means for your career, whether you're writing your first SQL query this weekend or deciding what to hire for next quarter. If Sue just to show you the destination, Edmondo's about to hand you the map, the key, and the salary guide. Edmondo, over to you.
Thank you, Louis and Sue Lee, and good afternoon, everyone. We are living through one of the greatest technological shifts since the internet, and artificial intelligence is dominating every headline, every boardroom conversation, and starting to enter everyday life. But the foundation of AI is data, and AI is fundamentally data-driven. Now, every company globally is trying to figure out how Gen AI, large language models, and machine learning will reshape their industry. The most critical role in AI isn't the person with the PhD. It's the person who understands the raw material that makes AI possible, the person who masters data analysis. Now, there is immense promise and excitement, and today I want to share insights for those of you who want a career in this new world, but aren't sure where to start. Today, I want to show you why starting as a data analyst is the most future-proof career foundation you can build and kickstart. Wherever you are in the world, welcome to today's session, and I'm thrilled to be able to share real-world insights and career recommendations about fast-tracking and future-proofing your career as a data analyst. I've been in IT for over 30 years and worked at a time where technology has disrupted the way we live, work, and play, from the birth of the internet, virtualization, cloud computing, and now data and AI. I've worked with individuals and organizations develop their careers and teams during this age of technology disruption. Now, I'd love to share more with you beyond today's session, so please feel free to connect with me via LinkedIn. So let's kick off this session about a career in data analytics with data. As Snowflake's CEO, Sridhar Ramaswamy states, there is no AI strategy without a data strategy. This means AI's power is limited unless the foundation of data integrity is ready. Now, while 88% of early adopters report material efficiency gains when using Gen AI, a staggering 62% of data systems are not yet ready to fully leverage it. This massive underutilized volume of data creates a limitless opportunity for your career in the industry. Now, here are some more interesting data points. To become data-driven, many organizations are recognizing that they need to address data literacy skill gaps across their business. In a recent Forrester survey, up to 73% of organizations' data is untouched for analysis, citing a lack of available skills. Now, 43% of respondents believe that upskilling to be their most urgent priority to unlocking that data. At the same time, 34% of CEOs believe that skills gaps in data analytics are the most crucial threat to their organization. But what has changed? Why the sudden shift to unlocking this data? Simply, it was the advancement in technology. 10 years ago, an analyst spent 80% of their time just trying to find the data and glue it together. It was a lot of manual work. Data lived in silos. Marketing had their database. Sales and logistics had theirs. No one talked to each other. Today, thanks to platforms like the Snowflake Data AI Cloud, the tedious part is largely automated. Data from sales, marketing, and logistics isn't siloed, it's unified. And now, why does this matter for your career? Because it means you don't spend your day working with broken pipelines and trying to find the data. You spend your day being a detective. You spend your time in high-value analysis that actually impacts the bottom line. You are a decision accelerator. Starting as an analyst provides the intuition necessary to build effective AI models. So if you want a resilient career, become the person who knows how to find, refine, and govern the data itself. Become the backbone of that intelligence, the data analyst. Previously, a data analyst was viewed as someone who spends their day cutting and pasting things into spreadsheets. Analysts were seen as gatekeepers. You had to ask them for a report, wait for it to be produced, sometimes taking many days, and get the report that was obsolete the moment it was printed. Their job was to report on what happened. Today, the data analyst is a translator and an accelerator. You sit right at the intersection of high-level business strategy and deep technical capability. Your job isn't just to write code or to show what happened. Your job is to be curious, to ask the right questions. It is, why did it happen and what do we do next? Your role is to turn business problems in a precise data query and then translate the answer back into a story that drives strategy. Data analytics in the AI era serves as a critical bridge between raw data and actionable business insights, leveraging both traditional analytical methods and now AI-powered tools to extract, clean, and analyze and visualize data. So what are some of the key tasks? Well, the data workflow. You need to be able to collect, clean, and structure the data. You need to be able to analyze by performing statistical analysis to find those patterns. Visualization is important. So how do you create those dashboards, reports, and interactive visuals? AI and ML support is now becoming more and more important. So your role will be to prepare data and validate machine learning models. You need to be able to convert data insights into business recommendations to drive strategy. You need to make sure that the data integrity is never compromised. Great quality data produces great outcomes. And finally, communications. You need to be able to present your findings to non-technical stakeholders. So what skills and experience are needed? What is the career path? So fundamentally, at the beginner level, you need to have technical skills, basic SQL skills, and skills across data visualization, across tools like Tableau and Power BI, for example. Soft skills, critical thinking, being detail-oriented, and having some basic business acumen. And AI tooling. Having familiarity with AI-assisted tooling will be really important in this massive shift. At the intermediate level, you need to build on those technical skills. So having advanced SQL and Python skills will help you with statistical modeling and database management. At the analytical level, you'll have the ability to produce predictive analytics and advanced visualization. Your AI skills will be used to design ML models and outputs and understand and interpret algorithm limitations. And at the business level, your domain expertise and project management and data storytelling will be critical in driving strategy. Now, over the years, you'll develop that expert layer and your technical skills will advance into advanced programming, big data across cloud platforms. At the strategic layer, your advanced statistics and experimental design across data architecture will be critical as well. Your AI leadership will enable the organization to develop AI models and interpretation, bias detection, and ethical AI. And at a management level, you may develop team leadership, strategic planning, and cross-functional collaboration, and this will set you apart. Now, the way we work, hire, and advance our careers is changing. Employers are looking less at job titles or degrees and more at what people can actually do. But that shift is also creating uncertainty. Now, according to a recent LinkedIn survey, Skills on the Rise 2026, 1 in 5 professionals globally say not having the right skills is making the job search more challenging. So people skills matter more than ever. Skills like cross-functional collaboration and stakeholder communication are increasingly in demand. As technology becomes a bigger part of everyday work, the ability to communicate with clarity through uncertainty has become critical. Business growth in a competitive landscape. Business and revenue growth skills like go-to-market strategy and business development are rising as companies focus on strategic revenue growth and expansion into new markets. Interpreting data with a business perspective provides the necessary context when sharing these insights with decision makers. AI goes beyond just coding. With AI moving quickly from experimentation to implementation, demand for technical and strategic AI skills is growing, focused on the development, iteration, and deployment of AI ML models. We are also seeing AI business strategy skills on the rise as companies integrate AI into core business products, services, and processes. Managing risk in a more complex environment. As regulation, security, and financial environments continue to evolve, risk and compliance will help companies manage risk and security with greater accuracy and efficiency. All of these are key non-technical skills required by a data analyst in the AI era. Now, as of early 2026, data from the online recruitment website Indeed indicates that entry-level data analyst roles are in high demand globally, particularly for candidates with foundational technical skills in SQL and visualization tools like Tableau. Now, while salaries are vary significantly by region, the role remains a lucrative entry point into the tech and business intelligence sectors, with a strong focus on data cleaning, dashboarding, and interpretation. So when you look at the global salary summary for entry-level positions for those with under 2 years of experience, in the US, entry-level data analysts can earn anywhere between $46,000 to $85,000, with a higher concentration in major tech hubs like San Francisco and New York. In Australia, entry-level salaries are high, often ranging from 75 to over 100,000 Australian dollars, especially in cities like Sydney, Canberra, and Melbourne. In India, entry-level roles generally range from 2.5 lakhs to 6 lakhs per annum, with significant increases at the mid-level. And across in Europe, junior roles typically pay between 28 and 45,000 euro, varying by country, with higher salaries in Northern European and for those tech-heavy positions. In 2026, the most common entry-level data analyst roles on the recruitment site Indeed frequently include junior data analyst and junior data science, focused on data structure, business requirements, and integration. BI analyst at the junior level concentrates on SQL, reporting tools, and data modeling. Data quality and annotation analysts focus on cleaning data and ensuring accuracy, often in sectors like finance or with AI-specific roles. For those graduates, the graduate data analyst is a rotational training-focused role for recent university graduates. An associate data analyst, support roles in data management, validation, and documentation are also in high demand. But what are some of the common responsibilities and required skills? Well, they all require technical skills. SQL, that is essential for querying. And if you have access to Excel or those type of tools, pivot tables and VLOOKUP is important, as well as the data visualization. Now, core duties will include cleaning, shaping, structuring raw data, maintaining dashboards, identifying patterns and trends, and presenting findings to stakeholders. And with AI integration, 2026 trends show a rise in the use of AI tools for generating queries and for summarizing insights, making familiarity with Gen AI an absolute bonus. So which industries are hiring and what are some of the trends and benefits? Well, finance and fintech are consistently high payers and they are looking for people that focus on precision. In the tech and software areas, they also offer a high-paying base and in many cases stock option. In the retail e-commerce sector, these volume-heavy industries are a great area for learning and they do offer highly competitive salaries. So regardless of your location, the themes from job requirements are the same, from strong written and verbal communication skills, problem solving, along with a key programming language like SQL and Python, as well as data analysis skills. They are the mandatory must-haves. Other roles of similar titles that are in high demand and similar to those of a data analyst include business analyst, BI analyst. You can have specific functional roles that include marketing analyst, financial and research analyst, along with those with a broader scope, like a reporting analyst. To simplify this further, let's look at the key requirements across all of these roles and how you can elevate yourself and become the business translator. Focus on these three key aspects. First, SQL, structured query language. It is the non-negotiable language of data. It is how you talk to data. You have to know it. Second, business acumen. You cannot analyze data in a vacuum. If you work in healthcare, understand patient outcomes. If you work in retail, understand margins and supply chains. Third, and most importantly, is communication. You can find the greatest insight in the world, but if you cannot explain it simply and persuasively to a non-technical manager, its value is zero. You must be a storyteller. So remember, tech skills are critical. Soft skills will differentiate you. Now, I often hear from people who want to skip the analyst role and go straight into becoming a data engineer or an AI engineer or data scientist. However, I firmly believe that starting your career as a data analyst is a critical launchpad for a successful career. It is your global passport. In my experience, every exceptional AI specialist or machine learning engineer is an excellent data analyst at their core. They deeply understand their raw material, the data itself. So starting as an analyst teaches you the complexity of unstructured data, where the biases are hidden, and how a company actually collects information. Without that intuition, you risk building models that will confidently make inaccurate predictions. By beginning in analytics, you aren't delaying your career. You are building the strongest possible foundation for it. Now, this role allows you to learn how data behaves in the real world. When you eventually move into building complex AI models, you will possess a level of intuition that those who skip this step often struggle to develop. Ultimately, analytics is a necessary prerequisite for anyone aspiring to be a data scientist, data engineer, architect, or even a chief data officer. It is the groundwork for a successful long-term career in technology. As I said before, it is your global passport. So why do analysts make the best AI practitioners? Well, you can't build models on data if you don't understand data. And what do I mean by this? Well, as a data analyst, you are mastering the foundation. Your role builds 4 critical capabilities that transfer directly into an AI ML work. First is SQL and data wrangling, the ability to clean, transform, and query the data set. Statistical thinking, understanding distributions, outliers, and significance is exactly what model validation requires. Digital visualization, translating numbers into story is the same skill needed for ML. Domain expertise, knowing the business context behind every metric is what separates useful models from academic exercises. Now, when you become an AI and ML specialist and you're looking at building your career for the future, every core machine learning engineer skill map backs back to an analytics foundation. Feature engineering requires work knowing which data matters and why. That's analytics work. Model validation demands the statistical rigor analysts practice daily. Explainability and storytelling. Stakeholders need to know insight, not just predictions. Data pipeline and mastery. Models fail on bad data, and analysts are the ones who know data quality best. So the key message, analytics is not a lesser role than data science or data engineering. It is the necessary prerequisite. The best AI practitioners started as analysts because they understood the data before they tried to model it. So how do you begin? Well, you don't need another 4-year degree. You need practical capability. Your roadmap is simple. 1, learn SQL and get really good at it. SQL, or structured query language, is the essential language used to communicate and manage data in databases. It is a foundation for all modern data analysis, allowing you to translate complex business questions into precise data queries. It is the foundation for everything a modern analyst does. Python is also highly recommended. 2, pick a platform like Snowflake. It allows organizations to bring all that data together in one governed, accessible place. It handles the heavy lifting of infrastructure. 3, build a portfolio. Spend your time on high-value analysis that has an impact. Build and showcase the output of your highly valuable work and how it has helped to drive positive business outcomes. 4, storytelling. This brings everything together. Your ability to convey a compelling story, leveraging your insights and providing a strategic view and recommendation will drive business strategy. Become a business influencer with data-driven insights. Now, a key takeaway, hands-on learning through both authorized and technical training and real-world experience, coupled with industry certification, are the 3 key pillars to fast-track your career. Now, before we go any further, I recommend you grab your phones and capture this QR code. Now, this will take you to the Snowflake education website, where you'll find a large catalog of learning content and information to kickstart your learning journey as well as your career. Ultimately, what will differentiate you is hands-on practice through labs and personal projects. Showing you can apply that knowledge in a practical environment is what gets you the job. Snowflake has made an incredible amount of training resources available to get you there. Snowflake University offers hands-on courses that teach you how modern businesses handle data at scale. They provide a wide range of instructor-led training with real-world lab environments. And also take a look at SnowPro certifications. Getting certified isn't just a badge for LinkedIn. It's proof to an employer that you understand the modern data AI landscape. So let's talk through the Snowflake recommended training and certification roadmap to becoming a data analyst. Firstly, Snowflake's definition of a data analyst is someone who specializes in the Snowflake AI data cloud. You generate actionable insights for business teams. Your role involves creating reports and dashboards tailored to those needs and facilitating informed decision-making. You possess the agility to explore structured data ad hoc, uncover hidden patterns. Your analysis empowers teams to leverage data effectively, driving strategic initiatives. So let's take a deeper look into each of these groups. Firstly, the hands-on badge series is ideal for those new to data or new to Snowflake. These free on-demand, learn-at-your-own-pace courses allow you to explore foundational concepts to build your skills. They are a practical, hands-on approach, a combination of videos, knowledge checks, and labs. So you get to build your knowledge in a practical, hands-on way, not just theory. Now, upon successful completion of each of these courses, you will receive a hands-on essential badge. Now, there are three: data warehousing, data collaboration, and data lake. But by far, the most comprehensive and effective learning comes from instructor-led training. It is critical, regardless of the platform you decide to learn on, hands-on skills are a must to gaining your desired role. This teaches you the real-world in-demand skills to aid you in your role as a data analyst. At Snowflake, we recommend the 2-day Snowflake Data Analyst course delivered by Snowflake industry experts. It takes you through the complete data analyst lifecycle, from connecting to data, querying, interpreting, and presenting outcomes. These courses are a combination of lectures, demonstrations, workshops, and real lab exercises that enable you to gain the confidence you need to perform the task as a data analyst. Now, if you're looking to build upon this and want to delve into a more predictive analysis, the Advanced Analytics course provides participants with skills to begin accessing information that supports a more predictive approach to identifying what could happen instead of only looking at what has happened. It introduces some of the AI concepts and introduces you to Snowflake's language learning model and machine learning capabilities. You may also wish to undertake additional instructor-led training to further increase your knowledge and employability, given the fast-paced nature of the industry, especially in areas like AI. And finally, certification is the perfect way to validate your in-demand skills against Snowflake's best practices. Employees are seeking these certifications as a way of identifying skilled data professionals who can apply real-world solutions to drive business outcomes. Now, employees are seeking vendor certifications as a way of identifying skilled data professionals who can apply real-world solutions to drive business outcomes. Now, Snowflake provides resources to aid in certification preparation that builds on the training, and that includes exam preparation content, exam preparation blueprints, practice exams, to name just a few. Now, there are 2 levels of certification available through Snowflake. There are 2 levels of certification for a data analyst. The first is obtaining the SnowPro Core certification. Now, this here validates your practical hands-on experience with Snowflake AI Data Cloud. And then the SnowPro Advanced Data Analytics certification. Now, this validates advanced knowledge and skills used to apply comprehensive data analysis principles using Snowflake and its components. Now, one of the other questions I get asked a lot is, will AI replace the data analyst? The answer is categorically no. Gen AI can write SQL code now, it can summarize charts, but AI cannot sit in a meeting with a frustrated product manager and understand the intent behind their question. AI cannot understand the nuance of corporate strategy or navigate organizational politics to get a decision made. AI will replace the boring parts of an analyst's job, the code generation, the basic formatting. The good news is it frees you up to focus on the human parts: curiosity, strategy, and judgment. This is the reality of modern enterprise technology. The data analyst is the structural engineer, the architect of intelligence who ensures the foundation is solid, and without you, AI sinks. AI transformation is happening, but it's not magic. It is an architectural achievement built from data, one query after another. You can be that architect. Don't just be a spectator to this disruptive transformation. Don't just be a consumer of AI. Become a translator. Be the foundation. Become a data analyst, the architect of intelligence. Now, your career starts with that first query. The industry is moving fast, so start building today. So thank you. I look forward to your questions later on in the session, and back over to you.
Wow, Edmondo, thank you. That was ridiculously practical. I've been in this space for over 2 decades, and I was still taking notes, actual notes on paper, like a data analyst from 2005. Okay, now it's your turn. We've got both Sue and Edmondo here for the in the next probably only 2-3 minutes, but they are ready to go deep. So drop your questions in the chat or Q&A panel right now. Day-to-day challenges, skill to prioritize, salary expectations, nothing is off limit. The only bad question is the one that you don't ask. So let me have a look at the questions, and we have our experts actually answering the questions in real time. So hopefully a lot of these questions are already answered. But there is a really interesting question, and a few people actually been asking very similar questions. So this one is for you, Sue. The question is, why SQL mastering is still essential? I have heard that the tools like Snowflake generate SQL automatically to retrieve data. What's your view on this? Sue, you might be on mute. Okay. All right. So while Sue is actually coming back on stage, I think she's got a bit of a microphone issue. But my take on this is that it's still extremely important because first of all, the AI-generated SQL still need to be validated, right? And even though AI generates a really good SQL these days, you as an analyst need to really understand the join, the aggregation, and how data is actually structured. So which is very, very important because SQL is more than just a writing queries, right? And it's a way of thinking about data. So it is for you to really have a logical way of asking the right questions. So Sue, in Sue's presentation, she did mention about asking the right question, right? To get the right answer. So having that logical thinking is basically what SQL teaches you. So what about you, Sue? What do you think?
So sorry, I was on mute for the couple of minutes. So that's actually going back to your question. It's a really great question. It is really true that modern tools like Glean AI Assistant and platforms like Snowflake can generate SQL automatically, but SQL, like learning SQL, is still very essential because it helps you understand how the data is actually structured and it can be retrieved. So AI can write the SQL queries for you, but you still need to know how to validate the results because like AI can be wrong sometimes. And you also need to, when the result is not accurate, you need to know how to debug issues and ask the right questions to actually complete the feedback loop. So in many ways, SQL is becoming less about memorize the syntax, but still it's very important. It's becoming more important about understanding how like data works. And once you understand the SQL, you can work much more effectively with both traditional analytic tools and now what's available as AI powered systems.
That's a great answer. Thanks for that, Sue. And maybe one last question for you, Edmondo, and please keep it short. I think we're on top of the hour.
Sure.
So the question is cloud skills still necessary in this day of age with AI? So I think the question is talking about things like AWS and Microsoft Azure.
Having a background or a thorough understanding around cloud is extremely important, because the scalability that you get with clouds is extremely important when you're dealing with large data sets. Okay, and businesses are wanting to make informed decisions very, very quickly. So having an understanding of cloud computing around storage and all of those aspects are extremely important, because data sets are inherently stored on these cloud providers. So having a background or an understanding of how cloud technologies work is extremely valuable, especially when we're talking about moving into the fast-paced world of AI.
I fully agree with you, Edmondo. And also, it's still, at the end of the day, it's the human interacting with other humans, and having to able to have that conversation around the backends. The understanding of cloud is super essential. So thanks for that. We could honestly keep going for another hour. These questions are brilliant. But I made you a promise at the top: respect your time and make sure you leave with a clear next step. So that's a wrap on today's Data and AI Fast Track. A massive thank you to Sue Lee for showing us the real, unfiltered life of data analyst. No Instagram filter required, right? And to Edmondo Rossini for giving us the career roadmap with actual street name on it. Not just work hard and you figure it out, right? And most importantly, thank you to every single one of you. These 1,000 people showed up on Friday afternoon. That's 3,000 people. Some of you could be at the beach right now. Instead, you invested an hour in your future. That's not a small thing. So here is your concrete next step. Don't let today's momentum fade by Monday. If today has sparked your curiosity, dive into Snowflake platform training, live, instructor-led sessions covering all things AI data cloud. You will get hands-on labs, tackle real-world scenarios, get your own Snowflake account for practice. The best part? This training is certification aligned, meaning finish the course, complete the survey, and you will earn a complimentary exam voucher to become Snowflake certified. Free training, free exam, real industry certifications, all at zero cost. To keep building your skills, join our virtual hands-on labs, guided interactive sessions where you learn by doing, not just watching, totally free. Scan the QR code on your screen for details. Do you prefer self-paced? Our developer guides have product quick starts, industry use cases, best practices, all ready for you. Again, scan the QR code on your screen for your instant access. So now here's your full roadmap, our 6-part Upskilling Data and AI Fast Track series. Certification aligned, instructor-led platform training, virtual hands-on labs on trending topics, self-paced developer guides, and the opportunity to get your Snowflake certification. A complete path from learning to certification, all free. Are you a startup struggling with data? Join us for the inaugural Scalable Startup webinar on April 22nd, where you will get to hear firsthand from Hasha Kapre from Snowflake Ventures, the corporate venture capital arm of Snowflake, which invests in visionary companies building on the AI data cloud. Now, mark your calendars. Our next fast track lands Friday, 10th of April. Better data, bigger impact for people and the planet. Mike Johnson and Jennifer Bellicent are going to show how data is cleaning rivers, fighting disease, hitting net zero targets, and making communities safer through cutting-edge social impact technologies. Today was all about building your career. Next session is about using these skills to change the world. Scan the QR code on screen to register. Thank you for joining Fast Track Friday. Enjoy your afternoon, and I see you on the 10th. Goodbye.